This is a story about a story that I just wrote, kind of the background of it, and whether you're a data worker who works with data that looks like this, or data that looks like this, or data that looks like any kind of data, you can appreciate what I'm about to tell you. So, how do you build up a lifetime of experience to tell a story as to what motivated you to write the story? That's what my goal is today to hopefully give you some background as to why I wrote what I wrote, and then give you really the truth behind the frustration and the lack of productivity that I see in data workers today. So a few days ago, I wrote this article called "The Alteryx Advantages." It's been a week actually, and this article has had pretty good readership of 4,500 reads, something like that, which isn't bad for things that I write, which are very narrowly focused. But in the beginning, I said, why did I write this article? Well, I had three reasons to write it. The first one is that for years, I've been encountering people who fail to understand the capabilities, spirit, and intent of Alteryx. I want to help these people understand why Alteryx is a great software platform, why I prefer to use it, why it's better than competitors, um, and what led me to those conclusions. Where did this all come from? And if I'm not doing it for monetary gain, why am I doing it? Well, it really comes down to sharing 30 years, 35 years, or longer of doing work and explaining, how did I get here? So let's take a little journey. So wrote this article, but we got to go back to the beginning to understand, where did I start? Where did I come from? Came from a single parent household in Chicago, um, one in which my mom had to work a lot, didn't have a father, didn't have anybody helping me with homework. And my earliest memories are my quantitative skills began in fifth grade. And they began because I had a nice teacher from Denver, Colorado, who I had a crush on, best thing way I could say it. And her name was Debbie Land. And I did a huge amount of math work that year. This is my report cards from fifth grade. And if I look at them, I could see that I made great progress through the year. And my math went from B to B to A to A. And I was able to finish all of these concepts. So I had an outstanding math year, is what she said. And so that's when it all began. And that was really the first time I ever fell in love with math. Really, the first eureka moment was learning to calculate an average. So when you're born with a quantitative mind, when you're born with a brain that is designed to do counting and designed to do mathematics, there's a natural tendency to think about things in that way, in a quantitative way, and to prepare yourself for the future. So after that, after fifth grade went, if we go a little further down in the article, um, by the time I got to college, I had chosen geology, which was a random selection. And this geology work required only me to only do calculus one, but I wasn't satisfied with that. I went to calculus two. I was ostracized. My fellow students said, "Why are you trying to make us look bad?" And then they didn't understand why I would want to continue with the difficult math. But I ignored them and went on to take at least 10 more math classes beyond calculus. And I continued to take math until I couldn't understand concepts anymore. I tried to pass from the world of closed form analytic solutions into the realm of numerical approximations into the world of abstract math. I realized I was hitting a boundary with partial differential equations. And um, furthermore, I realized something about myself. I realized I wasn't a math theoretician, but rather I was a mathematical problem solver, conditioned by years of solving problems by myself. So that starting at a young age of doing homework by myself, working all the way through high school, working all the way through um, college, all on my own, doing everything that I could by myself. Well, I didn't understand that I was developing mathematical talent. It Never was told to me, never knew about it until one day in my mid 40s, there's a story in here about the scores. In my mid 40s, I found all of these standardized test reports that my mom had saved for me through the years. And as you could see here, mathematics, computation, concepts, problem solving, all in the 7 to 9 range through all of these years of school. And these scores, as I look back in time, these are representative of me as an individual, as a person who was born with a quantitative mind. Never knew that, never was given any guidance on it. So when I got to graduate school years, I took a natural pathway into programming from having that quantitative mind. And these are some of the early computers I worked with. So I just went from a mathematical problem solver into a computational scientist. Through the years, I used to read books like this, Donald Knuth's Art of Computer Programming. I literally used to study how to solve these kinds of problems. I used to do the mathematics of these early in my career. I did all kinds of testing of numerical codes, the development of numerical solution techniques, a lot of classic numerical analysis and numerical calculus, and all of these kind of computational things, including my master's thesis, which was a theoretical computational science type approach that was limited by computer speed and hardware. So in the early years coming out of graduate school, then I began to um, work on numerically computational type problems. And right out of the gate, like within the first couple months of working, something happened where I discovered a problem with a Microsoft software product. It was their Fortran compiler. This thing is documented in a phone call of a lifetime where 2 or 3 months after I tried to tell Microsoft they had a shortcoming in their software product, the the Fortran group leader called me and said, "Hey, we'd like to offer you a job. We want you to come to Seattle to work for us." Now, this was in 1987-ish, 88. I don't know I don't remember exactly. It's probably in the article here. And I asked them why, and they said, "You were right about the memory limitation. It was exactly as you described it to us. Nobody in the group knew about it. And we figured that if anyone could see that problem without having access to our code, you need to be working for us. So that's why we want you to work for us." And then I told them, "Look, I just got out of graduate school. I have no money. My family's in Chicago. I'm living in Knoxville. I've never been to Seattle. I don't think I could just move there right now." So at that point, I had no idea that what Microsoft would become or how that could have impacted my life. So just continued to work for a small engineering firm. And if you look at my resume, we start looking at that. These first 10 years of May 88 to June of 98, I was a special environmental specialist working on quantitative hydrology and the development of conceptual models, scientific computer codes, graphical pre and post processors for numerical models, and innovative methods of analysis. So for 10 years here, I'm down in the weeds writing code, writing things to display three-dimensional flow of groundwater and contaminants and velocity vectors and the theory behind the mathematics, and then leading into graphical rendering of these results of these codes. So that set the stage for my ability to understand what Alteryx does, as well as what Tableau does for visualization. So if you do that for 10 years, and then you follow it up with another 10 years of working for a bigger engineering firm, working on things like Everglades restoration, where we have integrated surface water groundwater model that is written in C++, and you work on that for a few years. And then you work with a guy like this, Dudley Benton, my coworker, and we cover topics like curve fitting, Monte Carlo, differential equations, numerical calculus. These are all of Dudley's books. When I look further into his list, we have particle tracking. We developed these generalized. He wrote the codes. I did the testing, did a lot of the theory work with him. The plume three-dimensional plume migration visualizations, Build 3D, which was a three-dimensional model builder. So all of this three-dimensional geometry and computation, and Dudley's one of the most brilliant guys in the world for this stuff. So he's a mentor and a coworker. What I realized through that second decade is that to develop codes that are general usage codes are way more valuable than one-off projects codes. Like if you write a computer code to solve one problem for one project, that's great, but it doesn't have applicability to other projects that you work on. And so I realized then after 2 decades that writing the general codes was much more valuable and much more challenging because you don't have limits being placed on domain sizes. You're just writing codes that can handle any kind of problem. And so if we go back then to the next step, um, after 20 years of that, then I move into statistical process control theory and writing software for that, for orthogonal designs, for Plackett-Berman design of experiments, understanding how you can use statistical design theory to optimize processes and to make things better. Now you've got computer programming, you've got mathematical problem solving, you've got statistical process control theory, and you begin stirring this up in a big bucket. And now I'm beginning to think like a problem solver. I'm beginning to get that experience with data from different industries, from different companies, data in different types, different sizes. Through this time frame, data is growing bigger and bigger. The problem is becoming more challenging, and the diversity of data sets is expanding. So it was during these years where Tableau and Alteryx came into my life, and I could immediately see that both of those programs were designed with an open-mindedness that said, we're not going to box you in to any particular solution type, or we're not going to box you in and say, this is only what you could use the code for, but rather we're going to give you an open platform like an artist would have, a canvas, and you can draw on that canvas. Anything you can think of in your mind, you can do it, and we can render it. We can compute it on Alteryx, and we can render it in Tableau. So this was now for me an awakening that said, we're in a software revolution, because I went through the hardware revolution for the first 20 to 30 years, and now suddenly we've got software that opens up your creativity. The software is data agnostic. It doesn't require you to work with NetCDF files or Oracle databases or Hadoop or whatever. You can use whatever you want. That's a total game changer. And to me, that's the brilliance of Alteryx and Tableau. Okay, so let's stop there for a minute. If we run this movie backwards, and I told you the story a different way, and I said that I spent 20 years in those initial years doing open source work, where I'm testing compilers, I'm getting different compilers to test one versus the other, I'm writing solution techniques and comparing them. I'm basically going from one product to the next. I'm never becoming a specialist in anything. I'm basically just trying to get things done. And what I realized was that I was spinning my wheels a lot, because by the time I would learn something, it would be gone, and then I would be on to something else. And so you could never gain a mastery of anything. So the open source world was developing at that time. We started having version control software. We had repositories to put code in, and these kinds of concepts were developing. But what I realized is that it was occupying too much time. It was taking too much time away from my creative abilities to just manage the environments that I was working in. Well, let's switch to this compiler. Then you have to learn that compiler. You have to learn its GUI. You have to learn the way that it does breakpoints and watch points and all these sort of things. And everything was different. I mean, everybody had, there was no consistency in the way things were done. So if then we move forward again, now moving up to the time where I come into General Motors about 6 years ago, I'm coming in with this problem-solving ideology of using Alteryx for data prep, Tableau for visualization, both of the tools I have there to work on them. And then now I have this big data environment with billions of records and all kinds of things to work on. Excuse me, all kinds of topics from vehicle data, from vehicle data to financial data to travel and expense data to theoretical things like signage and road networks. And I could take this problem solving approach and apply it very quickly to all of these different topics. And so year after year, I'm going bang, 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 just knocking out these projects. In the meantime, I'm watching a lot of other people work at the company who are having to do things with open source tools. And I watch them spin their wheels like I did for 20 years. Let's get Jupyter notebooks running. Oh, wait, it crashed today. Let's get this new technique. And no, we're not going to use that anymore. Let's switch to this. Let's switch to that. It's this constantly meandering pathway of what tools do you use to do the job? Well, we have SAS. No, we don't have SAS. We have this. We don't. Now we don't have this. And so when you don't achieve a mastery of a tool, you are a pawn in the game of just trying to keep up, just trying to keep learning, just saying, this is what you have to do to get a problem running. I watched a presentation the other day for an hour, which was all about Spark. And all it was an hour of a guy talking about the problems he had to overcome just to be able to do a simple thing, which is count some records. And I'm like looking at this saying, this has taken him months to learn how to count some records in the database. And that's just like an immediate thing you get in Alteryx. Just you connect to the data, you count them, you're done. And it's one tool, it's a summation tool. And yet this guy's having to worry about small files. He's having to worry about all of these different techniques that you have to use of what type of files you create, what are you reading, where are they going, all of this complexity. And it's that type of complexity and that type of extra work that you have to do that I realized early in my career is counterproductive. That when you're working in the open source arena and you're having to learn all these different tools and all these different packages and learn how to write all of the specific code, sure, you can do it. And yeah, you'll get good at it. But in those 5 to 10 years it takes you to do that, by the time you get to the end of it, you're on to something else. And I'm still knocking out problems, still solving problems with rapidity, with accuracy, with comprehension. And so that's really the story behind why I wrote about the Alteryx advantages, is because a tool like this frees your mind from having to worry about all those details that somebody who's young in their career, yeah, they're eager, they want to learn those things. But if they're focused on worried about, am I writing small files or how many files do I need to write? They're worrying about these details that don't matter. They don't help you solve the problem that you're trying to solve. So you end up with countless workers spinning their wheels, just dealing with the tools and technologies of the day, and they're not making significant progress on the project. And that's where the role of Alteryx is. That's the spirit of it, is getting shit done. And that's the best way I can tell you. It's if you've sat in the chair, putting time in the seat for 30 years, 40 years, then you'll understand it. But if you haven't, and you haven't tried to do these things with data like I've done, bring together billions of records of data from different disparate data sources, data that might look like this or data that might look like that. If you haven't done it, you can't appreciate it. So that's why I wrote the article. I think I've said enough. Thanks for listening.